Hello everybody, my name is Merten and today we will have a Jägermeister tutorial in Aspen. The tutorial is about flow sheeting in Aspen 8, the new interface of the Aspen software, and it is a tutorial to getting to know how to work with Aspen and how to use the interface in the right way. As I said, my name is Merten, I'm a PhD student from the ETH Zurich. When you have any ideas, any things which should be done better in the future, let me know. Here is my email address, and let's start the tutorial now. First of all, I want to give a small overview about the tutorial. The tutorial is divided in 3 different steps. First of all, I will describe you our flow sheeting or our problem which we will solve in this tutorial. Then we will have a small introduction to the new Aspen surface, where we can find, for instance, our thermodynamical properties, or where we can do our flow sheeting. And in the last step we will do our flow sheeting in Aspen in a live simulation. So this is our process which we are going to simulate in this tutorial. It consists out of a fermentation part and out of a distillation part. Whereas of course our product is our Jägermeister. What is Jägermeister? Jägermeister is a German liquor which is quite famous around the Germans and also around the world. Especially my grandmother likes it a lot. After eating, after a meal, you drink a small quantity of Jägermeister, not so much. For, I mean, I guess increasing the fermentation inside the human body. So, but today we will talk more about the fermentation in an industrial scale. Here we have our inlet stream, which consists out of glucose and water. As we can see here, 50% mass concentration water and 50% mass concentration of glucose enters our fermentation. The temperature of our broth will have ambient condition, which means 25 degrees. After our fermentation we have ethanol, CO2, water and of course some glucose which is left over in our fermentation product stream. This will enter our distillation column. In our distillation column we will have a separation between ethanol and water, most of the water. The goal of our distillation is to reach the concentration of our Jägermeister, which is written on the bottle 37 volumetric concentration, which is approximately 30% mass concentration. And so this means we will have a CO2, water and our main target, our ethanol in this stream, and our waste stream we will have less or low quantity of ethanol, water and our glucose. So let's start with the introduction in Aspen after the process description. This is a new Aspen interface which will appear when you start Aspen. It's very nice, has a very nice design. Here in the bar you can see different kind of options which you can directly access. For instance, the support center, which I like. So inside the Aspen there will open the support center where you can browse a little bit, or for instance live chat. You can do this when you are registered with Aspen, so you can talk actually to the staff directly, or the training, which I like. In this training you can go through various tutorials in Aspen. They are mixed between Aspen 8 and you can see Aspen 7 version. Also here is documentation about Aspen, so here you can find the Aspen guide and Aspen tutorials again. So it's very nice and it's a very general overview. When you want to start your process, then you have to click at new, and in our case we will start a blank simulation. When we want to start our simulation now, this window will pop up. Different kind of steps has to be done to complete our simulation. Um, Aspen is now very nice separated in a property, in simulation, and in energy analysis. And this property option, we put all our chemical specification and our thermodynamical methods inside. Everything which is regarded to chemical, which you can also see here with this nice beaker. And in our simulation tab, we can choose our blocks, our uh, unit operations, which we would like to use in our simulation. So let's start with our properties. What kind of chemicals do we need? Compound, specification, find. Let's put ethanol, which is very important chemical, of course, in our process. We will look in the database, and after some seconds, here's our ethanol. We can also put, for instance, our chemical formula inside when we are not so sure um, about the name. Let's put H2O inside, which is our water. Here it is. Add. And we need our glucose. So the glucose is named under the compound named dextrose, which has the same chemical compound. When you are not sure if this is actually the right compound, you could also have a quick look into the CAS number to make sure that you're right. And last but not least is our CO2. And here we go. Here you can also have a quick look which kind of databanks you are using. When you want to have another databank, you can do it here, and it's very easy. So we are finished with this. There's nothing else needed in the compounds section. So now we have to choose a thermodynamical method. So we go under specification. When you're not sure about the method, you can go into the method assistant, which kind of helps you to find the appropriate method. For instance, specify your process, chemical, and then you will find different kind of things. For instance, we are under 10 bars, and here it suggests a unified property based method. So let's take it. So finished. So easy. As you can see now, this part is already done. We have nothing else to declare in Aspen, and after defining everything here, we can go to our simulation. So, our simulation. Let's start with our simulation. First of all, we need a fermenter. So the fermenter we find in the reactor section, and we use this one. We name it Ferm. And when you push, now we need material streams, and you can see here when you go on the flow sheet window which kind of streams are definitely necessary, the red ones, and which are optional. This is our broth stream, and this is our distillation in. So now Aspen tells you what kind of information it needs. For instance, the streams, the broth, we will add it. We will add the temperature, for instance, which is 25 degrees and 1 ambient pressure. Then we have our mass flow. We do it in a small scale so that we can do it in our kitchen or so, our Jägermeister's distillation. And it's of course only an example, so don't take me too serious. And then we have our mass fraction here, and we say the broth stream should have 50% of glucose, and 50% of water. When you're not sure about which kind of chemical it is, you can also go here and you see the chemical formula, very easy. It's a nice tool from Aspen. So, we are finished and now he needs some more information about our block. So, we tell him that our temperature inside the reactor should have 32 degrees and it should also have 1.03 bar ambient pressure. And this is okay, vapor liquid. What kind of reactions do we have? The ethanol or the glucose will ferment inside the reactor to ethanol and CO2. This is the reaction for the fermentation. And when you do or when you write down the chemical equation on your paper, you will find also out the coefficients. In this case, it's 1 and -1, of course, and 2, so that the mass balance is closed. And the fractional conversion is in our example 0.89. So this means 89% of the dextrose or glucose should be converted into our ethanol and CO2. So, and now it's done. Nothing else to declare, and I would suggest that we only give it a try if this unit works perfect, and it works. Results available. Aspen tells us let's have a small look. Okay, for instance, I'm not the guy who likes to work with kilomole per hour. I'm more the kilogram per hour person. So I go in setup specification and put here. Oh, I put MET inside MET, the global unit set, and I will choose my mass here. So let's do it quick again. And then we will have here also kilogram per hour. So as we see, our input is right, and we have a fermentation process. Ethanol is produced. Dextrose, our glucose, is fermented. It's you see it's a smaller quantity here, and CO2 is produced. So the first step works fine. Let's go now to the second step. After our fermentation, we have our distillation. For this, we need a distillation column, which we can find under columns. When you don't know now which kind of column you should use, you can go here to in the right top of the window to the question mark to help, for instance, to find out what kind of things each specific column can do. Here we have our WATFRAC, and we can go, is there an overview? Which I can find, yes, here it's an overview about this unit. Let's have a small look, and here it tells us what he can and what he cannot do. So, anyway, I will use it. So, our WATFRAC is here, we name it this. And what we need now again is our streams. So, right click, reconnect destination, and we need another 2 streams. Our Jägermeister stream is coming here, our major product, Jägermeister, and our waste stream is here after the boiler, which we name waste. So, first step is what he needs is something for the distillation. We say, okay, equilibrium. We will start with 5 stages. The condenser should condense everything. What are we using here? I would like to use the reflux ratio of 0.3. That means 30% are going back into the distillation column. And I want to use our reboiler duty. So what do we have in our household? Perhaps a small 0.4 kilowatt heating device, nothing big. Let's try if it works out in our example. So we are finished with this tab. Let's go into the next one. Streams, what do we need? Okay, our distillation feed stream, which stage should it enter? Let's choose the third stage. And which pressure should the column have? In the first stage it should have 1 atmosphere, which is 1 bar ambient pressure. So it looks nice. This is a random value with a feed stream stage which I have chosen. You can also do a sensitivity analysis to find out which stage is the best one for your example. I will do this in another tutorial. Today is only simple flow sheeting to understand how Aspen works. So, nothing else to declare. Let's give it a try. Calculating and results available. Let's go to our results. So, we have our broth, we have our distillation in. So far, this is very good. We checked it before. Now we have our Jägermeister stream and our waste stream. Let's have a look. So we see here that, where's our ethanol here? That our whole ethanol is in our product stream, in our Jägermeister stream, only less quantities in our waste stream. We have water still here and a little bit of dextrose and 0.21 kilogram per hours of CO2. Let's do a fast calculation. If we reached our goal of 30% mass concentration, and yes, my calculator says positive, we have approximately 30% concentration of our ethanol in our product stream. So far so good. When you're also interested perhaps in the compounds concentration inside the distillation column, you can click you can very easily get a diagram where you can see that our ethanol in the first stage, which is the top stage, has a concentration of, oh, I did the mole. Let's do it with a mass, otherwise we get a little bit confused. So mass, select all again, and here we go. That in the top stage we have 30% of our Jägermeister and also 30% of our CO2. And here we have also a smaller concentration of our water. This is everything for today. Thanks for watching the tutorial. Have fun with the flow sheeting, and of course don't get frustrated with the troubleshooting. Good luck.